ready? Okay, ready? Then we have a MacBook Air. It's 2015, 2017. It's a low backlight. I'm just gonna start it to see if you guys will see how it behaves. Mm, so you guys can see that it's has an Apple logo. It almost looks like it has backlight. Let's do a PRAM reset because you did a PRAM reset already. Okay, let's try that because it almost looks like there is backlight, but yeah, let's see. Hmm. It almost looks like uh, yeah, almost looks like there is backlight. Let's try switch this off and see what we get. Nah, there's no backlight. Okay, it's just bright. I think it's because of the light that makes it looks like nah, it's no backlight. Okay, so let's see what we have on backlight output. Uh, so as you know, with the blue backlight replace, the first thing you want to do, you want to confirm what is your backlight output. That will basically give you a guide as to what to do. Okay, so this is an 820-00165. It's a 2015-2017 MacBook Air. Let's quickly open up our board view to get an idea of what is happening. 820-00165. Okay, that is so this is the board. Let's flip to the other side to let's go to J86 let us also open the schematic of this so that you guys have a better idea of what we are doing. uh, Documents 165, there you go. Okay, so let's go to J8300. Is it J8300? J8300. Um, okay, so here we are. This is our JT300. So I basically search for JT300 on our schematic. So this is our JT300. So it says our LCD connector. On our LCD connector, we will be interested in the backlight output line. So let's go back to the board view. Here, we click on this. We'll be interested in pin 3 and 4. And also we see something that pin 3 and 4 is also 1. In between pin 3 and 4, we have unconnected, unconnected. This is a brilliant design because before, this basically, because this is the highest voltage line on the connector. And the fact that there is an isolation between a not connected and then an unconnected line, this is really good. This is a really good form of design in terms of basically the highest the high voltage not making its way to a lower voltage line. We talk about that in depth in a different why that is important in a different machine. For example, like the touch bars, the 2018, the 2016, 2017, 13 inches and 15 inches. Okay, yeah. So we'll be interested in what we have on our backlight output. So pin 3 and 4, let's quickly go to our schematic. Okay, so we'll be pin 3 and 4. So it's going to be pin 3 and 4, this and that. You see that pin 3 and 4 are tied together here and then here. So it says PPHV underscore SO switch underscore LCD backlight. So that is going to be the backlight output line. Let us see what we measure on that. Now, if we check on our PP bus voltage on this machine, we can check on our PP bus voltage on the fuse here. We see that we're getting 8.3. Yeah. So what you want to do is let's disconnect the battery so that we have full voltage. So the 8.29. Okay, it's fine. Just connect and connect it back again. So I just want to make sure we have our 8.6 voltage. Let's check again. We should have 8.6. Yeah, 8.59.6. So that's exactly what we have on our. I'm supposed to have on our PV bus voltage with the SMC communicating fully. Now, on our backlight output, let us see. Now, another thing is we are not worried about image because we could clearly see there's an Apple logo. So we're not worried about image. We have gone past the stage of worrying about image. Because if you have a dark screen, you first need to establish if you have image on the screen before you move on to backlight. So, but in this case, that has been established. We do have image on the screen. What we don't have is backlight. We also have done a period reset. Perhaps the settings, it might have been a setting issue. But when you do a program reset, that should address if it's a setting issue. So it's definitely not an issue with the settings. So that has been done. Now what we want to do is we want to see what we have on our backlight output, and that we can find on this component here, which is C83, 8317, C7799, C7797, C7796, and D7701. So let us basically now. So another thing is whenever you see XW, that is where a signal makes its way from one part of the board to the other side of the board. You understand? So for example, uh, okay, now on so here you look at this now. See here, that is where this signal travels from this point to the other side of the board. So that is what it means by the XW now. Yeah. The Apple genius is in the house. So that is good, good. So that is what is meant by XW. So whenever I see the XW, that's what it meant. So you're not expecting to find the components there. It's not going to be a component there. It's just going to be. So whenever I see that, so that is what it. So XW will be where you get your. Okay. Now let's quickly see what we have on our backlight output. Let's. What do we have? Zero on that side, and then the other side zero. Okay, again, let's check that. Zero and then zero. Okay, so now two things whenever when you get zero on your outputs, on the backlight output, two things you want to confirm. How what is the state of your fuse? Now this is gonna what is the state of your fuse? If your fuse it's fine, then the next thing you now want to find out is if you have a short on your backlight output. So let's see what is the state of our fuse. On one side, what do we have? Zero. And then on the other side, what do we have? 8. So that is a blown fuse. So we have a blown fuse. The next thing we want to establish is why is our fuse blown. So what we want to do now is we want to disconnect the charger and then switch our voltage, our multimeter to continuity mode, and then see what we have. So before we go ahead and replace our fuse, we want to first find out why is our fuse blown. And then the one important thing we want to do is because we have voltage on one side and then but no voltage on the other side. So we have voltage on the PPL side, which is the pin one. However, the pin two, obviously, which is where we have the input of so let's Q7706. Let's quickly go to Q7706 to give you guys an idea why that is important. Q7706. So that is so basically that is the input power line to the backlight circuitry. So this is our F7700. That is the fuse. Now the V in of SOs. Now without this, our this MOSFET is not going to open, and if this MOSFET doesn't open, definitely there will be no form of boosting. Nothing is going to happen in the backlight circuitry because you do not have the PV bus is not going to come in. So the PV bus voltage is basically what gets boosted for what we now have, which will go through this DC to DC boost, which is what we now have as an output. Now, if we don't have anything here, nothing is going to happen. So we have PP bus voltage on pin one of our fuse, but we have 0 volt on the pin two of our fuse. The next thing we want to do is we want to find out if we have a short on our fuse on the backlight output. That will explain why the fuse is blown. Let's see if we have a short. That's one side. No. Again, one side. Okay, let's just quickly establish something. So ground, so that you have ground and then you have the main line. So let's see what we have on ground. Ground you have 0, and then the main line we have no short. So we don't have a short there, and then we don't know exactly what happened for the fuse to have been blown. So this basically is just a, it seemed to be just a thing of the fuse only. And then also, another thing you want to do when you are dealing with an issue of the blood fuse, also it's also good to disconnect the screen connector just to see if you don't have any form of corrosion on your screen. Sometimes the reason why that is important is if you have partial corrosion, when the boosting is about to take place, there will be a kickback on that line, and then the fuse will blow off, which is basically which is a safety measure for it. Now, if you now replace the fuse without having to check if there's anything like that, that may now damage. So the first time to fix that, you can just basically clean it off, scratch it off, and then that should fix the issue. But if the corrosion is still there, and then obviously you just go ahead and replace the fuse without checking for your short or without checking to see if that is corroded, and then just plug it back, that may now have to damage the screen cable. And then when that happens, you now have to open up the screen to replace the screen cable. So it's important to also disconnect that just to be sure that there is no and there's nothing that could damage the cable after the fuse is replaced. So now that we have confirmed that the issue is just a fuse, so we can run a wire. We can just run a tiny wire just to basically complete our fuse settings, what it's supposed to do. But then again, like I said, that has to be a tiny wire. It has to be a wire that breaks easily. We can do that. That is, if we don't have the choice of another fuse. But in this case, we have too many fuses, so we'll just go ahead and replace the fuse. So, and then another thing is that we do not have to take the board out, but then we have to find a way to protect the plastic here so that we do not burn the plastic while we are replacing the fuse. So what we usually would do, like in a situation like this, is to place something in between, like this. That will give us a shield over the plastic there, and then just grab a fuse. Okay, there's a fuse here. Let's see if fuse is fine. Before we let's see if that fuse is fine. Okay, yeah, that's fine. So let's see what I want to do. So I want to remove. No, not there. No.
So one of pin one, pin two, the disables one.
Yeah. So pin. So one side is obviously going to be the PB bus, and then the other side is going to be the so this is going to be your PP bus voltage. That's going to be 8.6 pin one, and then pin two. That is where it feeds into the backlight segment. So when the fuse is blown, obviously one side will still be fine, which will hold the primary voltage, and then the outputs. It's now where you have nothing on. So that is so. As that is now, let's make this ready also while this is getting out. So you do not just go ahead and replace a fuse. You have to be sure why the fuse is blown before you go ahead and just replace the fuse. Otherwise, you might just be having the same issue. And then the first time when it happens, you may have minimal damage, just the fuse blowing up. But now when you replace it now, you yeah, you may just go ahead, you may just be doing, yeah, and then you now have to kind of pay like a city price for something that's supposed to be small.
What happens if we flip the fuse the other way around?
By flipping, what you mean? The fuse is so the fuse, but the fuse blowing, yeah. So it's basically it's you have a break in between,
So any direction. Okay, it doesn't have pin one. No, it's not like a capacitor.
like a capacitor.
It's not like a capacitor. Check that. What's called polarized capacitor.
Okay, that is in its place. And by the way, you can also use a soldering iron to replace the fuse in a situation where you do not have don't have a. Okay, so let's just quickly clean that up. And so we're not expecting any type of um, issue after replacement because we have already checked to see that we don't have anything on that line before replacing. Okay, that is clean. The next thing we want to do now is let's see what we now have. Let's just should be sure we don't have a short and work on output. Okay, it's fine. The next thing we now want to do is power machine. Let's see what we get. Okay, so one thing I usually don't like is when I'm testing my machine, especially for backlight outputs, I usually do not like to use a charger, the battery. I prefer to use a charger in case there is a reason to disconnect power from it. I can easily just disconnect. Yeah, so let me use um, the that is okay. Let's see. I didn't see backlight the first time we started. I was pretty much concerned not to have anything blown. Okay, it's I don't see any sign of. Let's see what you have on our backend output. What we have on our pin 1, 8.5, pin 2, 0. Okay, now we have a problem. So the fuse blew again. So definitely there is something on that line that keeps blowing up the fuse. So what we now want to do is we need to now take the board out to find out why our fuse keeps blowing. But this is strange because um, yeah, there was no shot on the line, and however it keeps blowing. But now the next thing we want to do is we did check for a shot using continuity mode. However, what we now need to do is to check for a shot using diode mode because that will pick up something that continuity mode may not be able to pick up. So that's what we want to do. But then to do that, we now need to take out the board and find out why our fuse keeps blowing. Because if the first one blew and then the second one it's also follows the same, then definitely something is wrong on that line. On and definitely on the output line. So we need to isolate exactly what is happening. Hopefully, it's not the screen issue. So usually if it's a screen issue, it will be an issue with the cable, the screen cable, not the actual screen itself. So let us see what's going on that line and then establish um, why our fuse keeps tripping. So we usually say that for the antenna cable, for the small screw here, make sure the antenna cable is out before you basically remove that screw so you do not partially break the antenna cable. Okay, that is that. Let's put this aside. Just do a quick measurement. And also, by the way, when you are doing that measurement, you check with the diode mode with the screen connected and without the screen connected. Let's check on the other side. What's in visual inspection? Check. Um, okay, trying to see if everything is fine with our backlight driver. Okay, okay, that's still fine. Now let's check using our diode mode. See what's happening there. Red probe on ground and then black probe. Let's see what you get here. 0.2. That is low. So you see that couldn't be picked up using a certain using a continuity mode, but a diode mode that picks it up. So I'll show you guys what that should look like. That should be around about one point something, not one, not 0. No. Okay, that says OL. Okay, yeah. So yeah, that's fine. That's let me see something. Yeah. Okay.
The backlight drivers. Try this.
It's not. Backlight drivers. Yeah.
More like a common problem.
Yeah. It's let's see what's up with this one. Ish, it's taking off also. Okay, but 0 something is definitely low.
Should be 1 point something. Is it on your pin
Uh,
number 2?
so again,
Is it on pin number 2? It should be 1 point something.
no, the main line.
Okay.
So here when you
Backlight output line.
yes.
Yeah, it should be 1 point something.
It's which can find now. Okay, nonetheless, that is definitely that. So I don't. We don't have to. That's fine. So, but that is low. So let's just check that again. That is low. It's not supposed to be 0. Nah, that's okay. Let me see if I can find something on that side.
Oh, yeah, that's the
Which version is this?
uh, this is the one I was testing.
Okay. So this is yeah. So that is more like it. 0.6. Yeah, 0. Yeah, that is more like it. This is fine, but this is way low. Yeah, this is way low. 0.2, that's low. Okay, and then let's just put more load on the line. Let's see what happens with more load on the line. Okay, okay, so that is definitely low. 0 to 2, that is definitely low. So what you want, I want to establish is what is causing that to be low, which is why our line keeps tripping. So let's establish what do we have on that line. On that line we have okay, we have that, and then we have from here also it makes its way. Okay, so let's start by removing our caps to establish which one of them it's. So you may be an issue with the connector itself sometimes, but let's start by removing the caps. Hmm. Okay. I think this cap almost never fails except for corrosion. So what we now want to do is let's now see what we get with those caps out of the way. Uh, so okay, I suspected that is still low, even though it's still the count. It's that's still low. Okay, let's just do this. It's fine. It's fine. If any of it fails, if at the cap you see it will give you some numbers. So OL it's definitely fine for it. So okay, that's okay. So let's what so this is out, that is okay. Uh let's take out this diode, let's see. Mm, okay, okay. Okay. See that? Okay. I think we may find our problem somehow. Yeah. Okay. So let's put that back. Think we found our problem. Let's just put this back. And the problem is also not the connector. So our problem is on the other side of the board. Okay. So our problem is on the other side of the board. So which is gonna be, yeah. It's, let's take
Backlight driver.
backlight driver out. And let's put back inductor, the diode. Okay, that's back. Now let's see what we have. Uh, yeah, that's about what we should also have. Now we need another backup driver. Let's quickly do this. And then in the same token, we just need another back. Okay, that's that. Let's get another. Let's grab. Backup drivers very scarce. Very scarce. You almost don't see. Okay, let's save promising. Let's check that out. This seems already been used, but let's just hope it works. So for this one, we have to snap it in place. Yeah, like that. Just make sure it's not skewed. Okay. Okay, now let's see what we have on our output. Yeah, that's about fine. Especially because it's increasing. That's fine. The next thing we want to quickly do is let's quickly put in another fuse. We could at this point just put in a cable just so we can do our testing, but it's fine. Let's quickly let's do this. This looks like a blown fuse. We'll check that in a minute. see if the fuse is fine. Okay, fuse is fine. Let's check diode mode. Uh, mm, okay, it's not so promising, but we can do with that. The
Might be the backlight.
no, no, no. The problem was the backup driver. I'm talking about the backup driver that we have in there now.
Yeah, that's what I'm saying. It could be having issues.
Yeah, because I see the reading I'm getting, and also, but also because also another thing with that, it's because of the state of the board, how hot it is, that can also affect the readings that you get. So let's quickly see what we have now. The backlight driver we may have to, because I really not do not trust that backlight driver. But let's see what we get in the output. Yeah, so we don't have. Let's see. At least do we have at least? Do we have? Yeah, that's fine. We have backlight output. We just don't have boosting. It's fine. It's progress. Now let's just get another backlight driver. Hmm. Okay, let's quickly get another one. Can I have that board? Yeah. See if it's. Do you have anything? Okay. Let's use the same method to snap it in place. Okay, that's it. And that's handy. Okay. So give it. Uh, let's hope that backlight fuse that we got here it's fine. Looks innocent. Okay, so backlight is fine. So that's about it, guys. Backlight is, I'm just gonna show you that we've got Apple logo and the lines. So our problem was the backlight driver was creating a short and basically was burning out fuses. Put in the first fuse, got blown. We didn't afford to put in another one without finding out what is happening. And then yeah, we did check for a short using our continuity, but that didn't pick it up. But then we used diode, we could see that there is an issue on that line. So as you guys know, testing for backlight, we just need this pin connected and the DC jack. We don't need anything else connected. Just wait for it. Okay, that's it. That's Apple logo, guys, and that is the end of our repair. This gets put together, goes through the standard testing phases, and then this can go to the client. Thank you, guys. See you in the next one.